Dear viewer, thank you again for tuning into my channel called The BPO Theory. My name is Peter and this is the third video in this channel, and this time it is titled The Joy of Physics. We now also have a subtitle, and that is Or How to Blow Up Dark Matter. In fact, in this video I'm going to replace dark matter with a competing concept. This video is not only about physics, but also about a mental state that I want to convey. A mental state where you can feel free to enter the arena of competing ideas, where there is a free interchange of thoughts with your peers. That is what I think physics should be. There is much joy in trying new points of view and new tactics of explaining observed phenomena. And I'm going to give you one such a new tactics in explaining the behavior of galaxies. Yes, galaxies of stars. I will show you an alternative concept that can possibly replace the concepts of dark matter and dark energy. You probably heard of those two concepts. Estimations go as high as that the universe is made of about 80% of dark matter. The matter we see, say the stuff that we are made of, is only the 20% portion. The rest is dark matter. And then if we take the energy that is in all this matter and dark matter together, there must even be more dark energy. Well, yes, not just dark matter, but also dark energy. So the contemporary thinking in this arena of thoughts is that normal matter is only about 6% of all the stuff that is in the universe. Now, first I would like to explain why many physicists think that there is such a thing as dark matter. I will not go into dark energy much because I want to concentrate on dark matter. Otherwise this video will become too long. If you are curious, want to hear the whole argument, including dark energy, there is a more comprehensive article that you can download by following the link below. And then after explaining dark matter, I would like to direct your attention towards an alternative theoretical concept, namely repulsive gravitation. And then I would like to show how this concept could eventually be a substitute for these dark things. Now, first, let's have a look at a galaxy of stars. Now, this particular one here contains 10 billion stars, and that's not even a big one. Some have more than 1 trillion stars. And then consider that we have about 200 billion of these galaxies in the universe. It's rather a big thing, the universe, isn't it? Now, to travel from the one side of this galaxy to the other side, a light particle must travel about 100,000 years. So if we had a spaceship traveling at a near light velocity, it would take millions of years to properly populate this galaxy with humans. And then we would still have some 200 billion galaxies to go. Now, if it takes light 100,000 years to travel from the one side to the other, it takes light about 50,000 years to travel from the center to the outskirts, isn't it? Now, if you look at such a galaxy, you see that there is more light in certain parts than in others. The center, for example, radiates far more light than the outskirts do, and so you can estimate the amount of stars at a particular location in a galaxy by looking at the intensity of light. And from that you can infer how the mass of these stars is distributed over the galaxy. Much light means much mass. That's the logic. Now, a comparison with a solar system could make it easier to understand what this all means. The Earth and all the other planets revolve around the Sun with a specific speed, and they do so because they need a centrifugal force to counter the attraction of the Sun. And for a centrifugal force, you need motion. Like, for example, when you circle an object on a wire around you and you feel the object pulling at you. So if a planet would not revolve around the Sun, it would fall into the Sun. What we see in a solar system is that the Sun has much more mass than the planets around it. Look at how big the Sun is in comparison to the planets. Now, this creates a pattern of motion for the orbiting planets, where the planets that are farther away from the Sun have lesser speed. You can see that in this simulation here. The Earth, for example, somewhere here, has an orbital speed of about 30 kilometers per second, moving around the Sun. Whereas Saturn, being far farther away from the Sun, has an orbital speed of about 10 kilometers per second. That's only a third. Now, if you look at the mass distribution of a galaxy, you will see that most of its mass is also packed into the center, like what we just saw in the solar system. And so you would also expect that the orbiting speed of the stars around the center of the galaxy would also drop as you get further away from the center of the galaxy, just like Saturn moves at only a third of the speed of the Earth. But no, this is not the case. Researchers in the 80s of the former century showed so. If you get further away from the galaxy center than, say, some 10,000 light years, the speed of stars remains more or less the same. So instead of the expected lower curve here, where the speed of stars decreases, we see it remaining steady in more of this curve here. So all these stars here, after the first 10,000 light years, and then further away, orbit the center with approximately the same speed. Now here's an animation of how that would show up in a time lapse. There you have your great mystery. How can this be? Now, in this arena of thoughts, the physics ought to be, several explanations were put forward. Dark matter was only one of them, but this was the one that gained prominence because it could come up with some fairly adequate calculations. Now, the idea now is that in the center of the galaxy you only have normal matter, but then if you go more outward, some sort of matter starts to show up that we cannot see. And that strange type of invisible matter becomes more abundant as you move more to the outskirts of the galaxy. Until you pass the last star, you are left with a halo of dark matter there. So the density of dark matter increases with a certain slope. Now, we call that slope the dark matter gradient. And the effect of this dark matter gradient is that we do not have that much concentration of mass in the center of the galaxy anymore, since there is also much mass, although we cannot see it, further away from the center. And so if it does not look like a solar system anymore, then it does not need to behave like a solar system either. In effect, the speed of orbiting objects does not need to decrease with increasing distance from the center anymore. There we have our explanation. Now let's look at an alternative explanation. Remember, I promised you the joy of blowing up dark matter. Let us suppose that there is just as much antimatter in the universe as there is matter. Strange idea? Well, bear with me for a few minutes, don't walk away. In these large colliders that we have, for example in CERN, if we bounce protons off on each other, all sorts of particles are created. And it turns out that there are just as many antiparticles as normal particles are created. So if that is what happens in a collider, why would that be different for the rest of the universe? I mean, experimental evidence points in this direction. So in the arena of free thoughts, an equal abundance of matter and antimatter must be given fair consideration. But is it not true then that matter and antimatter annihilate when they get in contact with each other? Experiments indeed show that they destroy each other on contacts. Well, that is of course when they actually get in contact. But what if the one star is made of matter and a neighboring star is an anti-star made of antimatter? There will be no contact between the two, considering the distance between them. And we would not be able to detect which one is the anti-star either, because much research shows that an anti-star would radiate the same types of light particles as a normal star does. But then how would matter and antimatter have separated into separate stars? Well, imagine that antimatter attracts other antimatter. That would make antimatter flock together and form anti-stars. So in that sense, antimatter would behave just like matter. But now assume that matter and antimatter do not attract each other but repulse. I mean that their gravitation is repulsive. Think about this. If the Earth was then made of antimatter, it would be pushed away from the Sun. And a star would repulse an anti-star. And a galaxy made of predominantly stars would repulse a galaxy predominantly made of anti-stars. Think about that. Again, in the arena of free thought, this explanatory tactic deserves fair consideration. Would you think so? Now, how could this repulsive gravitation then explain the odd way in which stars orbit their galaxy center? Well, we could replace this dark matter gradient with an antimatter gradient. Remember that in the dark matter theory, dark matter becomes more abundant as we move to the outskirts of the galaxy. Now consider that we have just as much matter as antimatter in the center of this galaxy. And then if we move outward, antimatter steadily becomes more dominant. So instead of a dark matter gradient with an ever increasing density of dark matter, we have an antimatter gradient with an ever increasing density of antimatter. That would create the same effect, namely that the speed of stars remains more or less the same after a distance of, say, about 10,000 light years and further. Of course, in the example that I just gave, where we have an antimatter gradient, we would have a galaxy dominated by antimatter. If that were our own Milky Way, that could be a bit of a frightening thing, being surrounded by many anti-stars. But this concept works just as well in case you have a matter gradient instead of an antimatter gradient. Then, again, we have a mixture of matter and antimatter in the center. But as you move outward, matter becomes more abundant. That will create a matter gradient. And so you see that you can replace the dark matter concept with the concept of repulsive gravitation. They can both explain why stars have equal orbiting speeds around their galaxy center. Now, what has all this got to do with the BPO theory, since that is the name of this channel you are watching? Well, the BPO theory offers, unlike many other theories, the opportunity for matter to repulse antimatter, and vice versa, of course. And so, if we can show that repulsive gravitation can indeed be validated, that would show an explanatory asset of the BPO theory. But there is also another reason why this idea has got something to do with this channel. This idea of repulsive gravitation is entirely in the spirit of BPO, since the BPO theory is conceived in a spirit of exploration, of daring to redefine the basics of physics. With BPO, I do not stay in a safe haven of mathematical formalisms only, although they, of course, stay very important. The spirit is to create an innovative theoretical framework that offers numerous possibilities for further research and development. And one of these opportunities is to further formalize the gravity part of the BPO theory. You can read how BPO models gravity in the article that you can download following the link below, but it still needs a formalized mathematical form. And what would really give me joy is to engage with others in order to explore this idea further. And so there you have it. The joy of physics. It is not about formulas and numbers, although they are, of course, very important. No, it is about uncovering the secrets of a vast and enigmatic cosmos. And we do it together. It is about connecting the very small world of basic particles with the cosmic scale of galaxy clusters. To think, write and talk about such things all feels like a heroic endeavor to me. And you need a very open mind and a bit of a daredevil attitude if you enter a new continent of thoughts. Because otherwise you will be confined to its shores only. But you also need to think things through. Do not only float some thoughtful balloons, but think your ideas through in all their consequences. That is the spirit of BPO. And that is also the spirit of the attached article. So do please read it and become a daredevil. And do some of the suggested follow-up research. Well, that's it for today. If you like this video, do not forget to give me a thumbs up, tell your friends all about it, and subscribe to my channel. Thank you again for tuning in, and I hope to see you next time. Bye bye.